today, excuse me, we're going to talk about combinations, and that's about all we're going to get through. Tomorrow we'll get into the binomial theorem. Yesterday when we talked about the permutation stuff, that was when the order was specific. The order had to matter when you were working through some of these things. You had to be able to put the, when we're talking about the finish of the way that the ski jumps worked, where you had only 15 people, how many ways can you arrange the 15 where one person was in first, second, third, and so on. What's going to happen here today is where it becomes a little bit more complex because the order doesn't matter. Combinations are for when order doesn't matter. For example, I like to talk about a deck of cards. And I brought this up a little bit earlier today. Does everybody know all that you can about a deck of cards? There's 52 of them. There's 4 suits. 13 per suit. Everybody knows the basics on cards, right? I hope.
I know how to count cards.
No, none of this includes jokers whatsoever. Okay. There are what? 4 face cards: Jack, Queen, King, and Ace. Everything else is twos and stuff. Okay. 2 through 10. So when you're looking at a deck of cards, with there being 52 of them, if I shuffle them out and I just pick out 5 cards, does the order matter in which I pick the 5 cards?
No.
It doesn't. So this is where combinations come into play. So when we're dealing with cards, it's a non-specific order. It's just 1, 2, 3, 4, 5. Okay. So I start out with just 5 cards. In order to figure out how many different combinations you can come up with out of a deck of cards where the order doesn't matter, you use number, choose R. Okay. This is where order doesn't matter. So what you're looking at is how many total possible are there that you are selecting from. Well, I'm selecting 5 cards out of 52. So what you write is 52, choose 5. I'm picking 5 cards out of a deck. What's that? Again, when we looked at this stuff yesterday, where it was NPR, it was the n factorial over n minus r factorial. This one's a little bit different. This is n factorial over n minus r factorial times r factorial. Remember what factorial means?
Isn't it like 1 times 2 times 3 times like something like that, right?
Yeah, if it's 5 factorial, it's 5 times 4 times 3 times 2 times 1.
Right, yeah, that's right.
It's not 5! Sorry.
That's right.
So in this case, it would have been 52 factorial over 52 minus 5, and then 5 factorial. Yesterday, when we wrote that out, you guys saw that there were a certain amount of values that we're simplifying out. Back in the old times, pre-TI-84s, you actually had to multiply stuff out and simplify fractions. These were actually very easy to do by hand. You guys now have a button. In your calculators, if you go to, we were doing 52, choose 5. You type 52, math, left again, and now it's number 3 for NCR, and you're choosing 5. This means in a 5-card draw, there are 2,598,960 possible hands that you can deal. Okay?
Makes it easy to play poker.
Makes it very easy to play poker. Yeah.
Do you write like C equals or?
No, when you're writing this out, this is what this equals.
Yeah,
This,
okay.
you just leave it as
So you
that.
just leave it.
Yeah, it was 2,598,000, what was it?
8, 9, 6.
9. So the possible ways that you can deal a deck of cards, there's a little over 2 million ways. Bless you. Let's see if I win. How's that a full house? Do you know what a full house is? It's a very empty house. Now, this is not dealing with probabilities. This is just counting possible outcomes. Next week, when we get into the probability stuff, we'll use some of this to help count cards. Yeah. We'll use these things to get into, all right, how many possible ways can I get a royal flush? Can I get a straight? Things like that. What is the probability of those things happening? What's the probability of getting 2 pair? That's when you use and work back and forth. So that way you start to learn how to play poker, how to win.
Let's get it, baby.
Or when you start dealing with blackjack or 21, however you guys want to play it, when to sit, when to stay, and all that other stuff. Which we might have a little bit of time to try a couple of hands.
I'm undefeated in blackjack. I always beat people that wear masks made out of paper.
I tried to make this work on the smartboard, and it didn't really show up, so I might as well at least show you guys this.
Wow.
If I want to pick cards, there's my 5 cards. Thought it was kind of cool. It didn't work as well as I'd hoped. So there's your 5 cards. So you can deal cards on the smartboard. This stuff's cool.
Hey Murph, who's that one? Yeah, what funnel cake is that?
Oh, there was a funnel cake outside, whatever hour it was, and then they told everybody not to go out there. Were the dogs walking or something?
Yeah.
There was a funnel cake out there, and a girl thought she could bring it to class to eat. Said, no, the funnel cake needs to sit outside. After that, Holden actually made a joke. He goes, watch, today will be the day there'll be a random dog walking around the building. And seriously, 2 minutes later, they said close the doors because I'm assuming the dogs were out there.
Yeah.
That an actual dog was walking through the hallway. So if you know Holden, the fact, well, he didn't eat funnel cake, but the fact that he actually guessed something that was right is well beyond his own prowess, shall we say. So he was pretty proud of himself. So he got a point. Funnel cake lost. Might have got eaten by a dog, but it didn't.
Boring class, right?
Yeah, boring class, yeah. Now we have to start to think where we can get this more complicated. We're not just dealing 5 cards. We want the 5 cards to be of the same suit.
So,
I like it.
so the flush.
You want to deal yourself, how many different, this isn't just,
You want flush.
you're not trying to find probability here. You're just trying to figure out how many different ways can that be dealt where all 5 cards would be the same. So this is where you have to start to play around with what do you know about decks of cards. We've said this a second ago that in a deck of cards there are 4 suits and there are 13 in each of the suits. If I wanted to look at being able to pick where all of them are going to be the same suit, first thing I have to figure, how many suits are there? 4 of them. And once I figure out what suit I'm going to get, I have to pick, well, how many ways is it possible for me to pick one of the 4 suits? Well, that's the first step. You have a 4, choose 1. You're picking one of the suits. Diamond?
Yeah.
Was that right?
Yeah.
I guessed correctly.
Oh, did you really guess
I
that?
did.
Very
I did. No, I'm not kidding.
Guess another one.
So now, I've
Do it
picked,
now!
2 card pickup. In this case, I've picked a suit, and I want to make sure that how many different ways is it possible for me to deal out and have all of the rest of them be the same suit. Well, of that suit, there's 13 cards, and I need to make sure that all 5 of them are the same. This is one of those compounding styles, and you have to start to mix some multiplication in. You You're picking a suit, and you want all 5 of them to be of that same suit. So let's see. I guess I'm gonna lose. Nope, I lost. Still losing. Still losing.
Hey, you guys. Wow, red.
Wow, wow, wow. So the next person has this,
Oh, that's a good
and they win because they have a pair of 4s. Okay. So in your calculators, it'll do this for you. Suggestion that I will make is put parentheses around it. So it's 4, choose 1, times 13, choose 5. So being able to shuffle out all five cards being of the same suit, there's only 5,148 combinations of being able to do that. That means I have like a 2, 3, 4, 5, or a 2, 3, 4, 6, 8 of a diamond or whatever. Yes?
You know, it'd be mad if you like brought one of these like 284 or something with this, you know, you like really don't know you're gonna stay like pull up.
Yeah, you're not allowed to do that. I don't think, you're not even allowed to even have your phone out.
That's too good. So.
Yeah, you can't use your phone inside of a casino like that. They'll escort you out real fast.
Even in an emergency.
Well, you'd have to walk out to use it.
You're not allowed to have your phone.
You can't use it
Use it? Why?
because you could be looking stuff up. You could be cheating. You ever seen the movie Casino?
You ever seen Movie 21?
Have you ever seen the movie
Well,
Rush Hour 2? What? They go to the
they tend to look they tend to look badly upon cheaters in casinos.
kill
Well,
one.
well, they're the ones cheating us out, Mr. They're cheating
Yeah.
us out.
You didn't have to go in there.
Right? Tell me. Well, Street is a sucker.
Murphy, when your person jacks and then you meet the Lotus.
What's that?
Your person jacks and then you meet the Lotus, you can't stay away from it.
Yeah.
Okay.
That did happen.
That happened.
It's a true story.
Now, when you get into this more, when you get into this a little bit more, you can get more complex.
Thanks, Raya. You like my joke?
I'm Percy Jackson, so I got the joke.
Score 1.
Air high five.
Deciding whether or not to multiply or add these combinations. This is where some of the vocab within the problem becomes important, whether you see certain keywords. For example, if I'm looking at a menu, that sells or about omelets, if I'm going to choose exactly 2 vegetables and 1 meat ingredient for the omelet, how many different combinations of omelets can I make? I'm making an omnivore omelet.
That makes sense.
Eats vegetables and meat, omnivore.
That's a lot
So-
of most of the human race.
If I'm looking at this one, notice the word in between there, it says and.
Multiply.
When you see the word multiply, you're gonna think, you're probably multiply. When you see the word and, you're gonna wind up thinking multiply. So, you need to choose 2 out of the 6 vegetable options. 6, choose 2, times, how many, we have 4, choose 1. That gives you the number of possible choices that you can get for the omelets. And you get 60. Kind of along the same lines when you're thinking about that the Subway stuff. If you're going to Subway, you have 6 choices of bread, 8 choices of meat, this and so on and so on and so on. So these total possible combinations that you can make of these sandwiches are just immense. They're just huge. So when you multiply that out, you get 60. Now the little bit different part here. Suppose you can afford at most 3 ingredients. What does at most mean? At most 3.
Max.
Maximum amount is 3. So that means how many ingredients can you order? 3, 2, 1. I can have none. I could have just a fried egg. Because isn't an omelet with nothing in it a fried egg?
Yeah.
It's those cheese.
It's scrambled.
It doesn't say that there's cheese, it just says an omelet. Cheese is an option.
What?
Cheese is
No.
a vegetable.
No.
We're arguing semantics,
That would be
okay?
really poopy omelet.
In this case here, when you're talking about, you can afford at most 3. And at most 3 means you have to figure out how many different combinations of nothing could you make, how many different combinations of just picking 1, how many different combinations of 2. So you're adding those different combos up. So you have, how many total were there? Ingredients?
10.
So 10 pick none, 10 choose none,
10 to 1.
plus 10 choose 1, plus 10 choose 2, plus 10 choose 3. You can type those all separately, add them all up, or you can type it all in as a string if you like, it'll still work.
Wait, so what was the keyword for that?
At most. You'll see at most, at least. You'll see stuff like that because you're picking, I can do this one or this one or this one or that one. Yes. If you're going to do, let's say if you wanted to pick at least 7 of them, you'd go with 10 choose 7, 10 choose 6, 10 choose 5, 10 choose 4, and so on. You go that way.
I feel like that's Panera. You have to order cheese with your
I can't remember the last time I've been in a Panera.
It's nothing. There's no omelets in Panera. Give them -7, please. That's a minus for you now.
What, never been to Panera?
No.
No, Hunter. The concept was, is if you have to order the cheese with your omelet, then you probably would charge you.
I understand. Thanks,
What's so against, why are you so against Panera?
They're
Panera's
overpriced
actually pretty
restaurants.
good.
A theater is staging 12 different plays. You want to attend at least 3 of them. How many different combinations could you go to? You're saying, because there's an at least, this is one of those addition ones. So one way that you can do this is you can set it up as, if you're going to be at least 3 of them, so you're going to start, you have 3 choose, or 12 choose 3, 12 choose 4.
That's a lot to type out.
It's a lot. There's a shortcut.
Merv. Oh, you can just do the. No.
You can go backwards and subtract. So if we agree that we're going to be at least 3 of them, we need to first figure out how many total possible plays there could be. So think about if you're going to go to a play, you have 2 options. You're going to go, or you're not going to go,
That's it.
right? How many times do you have to ask yourself if you're going to go or not go?
12 times.
12 times.
24. No.
Go or not go 12 times.
Up to 12.
Okay? 2 to the 12th power is your total number of options that you wind up going for the mixing these things together. Go, not goes. From that, you could subtract out, well, if you're going to go to at least 3 of them, that means you're going to go to 12, choose 0, 12, choose 1, 12, choose 2. It's a little bit less work to type that out because those are the ones that you're not going to be doing. Because you're going to go to at least 3. So you're looking at total combinations of going. Go, not goes to the 12th power from total combinations. Instead of just adding them all through, which you can do, you're going to get the same answer. It's just showing you another way of setting it up. Some people are going to be more comfortable just adding them all together, adding up the 12 choose 3, 12 choose 4, and so on. That's fine, because you have calculators. Remember, a lot of times with this textbook, some of the methods that they show you guys with these things are tried to show you ways of doing things to shortcut it somewhat for you. So you don't have to do as much work. Because back in the day, we didn't have calculators with the NCR button, or the NPR button. You had to do a lot of this by hand. Yes, ma'am?
So the other way you can do it is just starting at 12, choose the.
Yep, go all the way up to 12. 3, 12 choose 4, 12 choose 5, all the way up to 12 choose 12. And you'll get the same answer. Yes, sir?
Wait, explain the 2 as well.
What's happening there is you're looking at the total possible ways that you can go or not go to the 12 plays.
Just 12.
Yeah.
Well, but you said the 2 is go or not go?
Yeah. You have
Don't go, you're not going to any place.
Thank you for your cooperation at this
I know,
time.
but the
Teachers, you
one-
once again
the
can
options.
start writing texts. Once again, thank you for your cooperation.
what happens here is you have go, not go. It's either yes or no to a play.
Oh, 2 yes.
Yeah. And how many different ways can you set that up? Yes or no. You can say yes, 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 no, 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 yes, no, no, yes, no, no, things like that. Doing that, there's 2 to the 12 different ways of letting out yes or no 12 times. Is what that is.
Not going all for
Yeah.
going all around.
Okay, does that make more sense? You're basically doing binary coding. Is what you're doing. You're doing binary code, 1s and 0s. So let's see if we can make this. No,
Oh, a little bit of homework.
a little bit of homework, which is about right on time. Because what I want to set up here after this is, there's no reason for me to jump into the Pascal stuff with writing out binomial expansion today. We'll work on that tomorrow. Read these carefully. The first grouping is dealing with cards. After that, you're going to get into a couple of the word ones. The first set of word ones are just combinations. I think the last 4 problems, you have to decide whether it's going to be a permutation or a combination. So you have to read it a little bit carefully. You might be able to pick up on it rather quickly. Okay?